This is the third lecture of week 6, and we're going to cover joint hypothesis testing for multiple coefficients. In the previous lecture, we talked about how to conduct joint hypothesis testing with multiple restriction involving multiple coefficients. So more specifically, last lecture, we had two coefficients, beta 1 and beta 2, and two restrictions. Beta 1 is equal to 0 and beta 2 is equal to 0. In this lecture, we're going to talk about still the two coefficients, beta 1 and beta 2, but only one restriction. And in this case, the restriction that we want to test is beta 1 is equal to beta 2. So this lecture will focus on how do you conduct the hypothesis testing when you have multiple coefficients but single restriction. So there are two ways to conduct this hypothesis testing. First is to rearrange the regressor as if you're testing a single coefficient. And we're familiar with this. We know how to do a hypothesis testing when there's only a single coefficient involved. Another method is to just conduct the test directly on software program. So Stata actually allows you to carry out the test when there's a single restriction involving multiple coefficients, and we'll show that as well. But we'll first go through the process of the first method just so you understand how it's done. But in real life, you'll only be using the second case where you can just directly test it on Stata. So we have a regression equation with two regressors, and we want to test the hypothesis if beta 1 is equal to beta 2. In this case, we can add beta to x1 and subtract beta to x1 from the regression equation. And since we're adding and subtracting, we're essentially not really adding anything. You can rearrange this by moving this over here and moving this over here. So now you can put it in this way. You can pull out x1 from these two and then pull out beta 2 from these two. So it becomes this equation. And once you have that, you can basically say that beta 1 minus beta 2 is some gamma 1 that we are interested in. And then we can just say x1 plus x2, addition of two regressor, is another regressor, wi. So in this case, we can say that we want to test if gamma 1 is equal to 0, which is basically the same thing as if beta 1 is equal to beta 2. So we have effectively transformed joint hypothesis testing with multiple coefficients into regular hypothesis testing with single coefficient. So if you regress y on x1 and w, which is equal to x1 plus x2, then the coefficient for x1 would be, when you test whether gamma 1 is statistically significant or not, or if you test if null is gamma 1 equals 0 versus alternative being gamma 1 not equal to 0, when you conduct this hypothesis testing, then this is basically the same thing as testing whether beta 1 is equal to beta 2. So we have done this many times before, so now we can carry this out. So what's nice about Stata is that the Stata actually conducts this joint hypothesis testing with multiple coefficients directly, so you don't have to transform any of these equations. So in our case of regressing test score on student-teacher ratio and expenditure per student and percentage of English learner, and say we're interested in if the coefficient for student-teacher ratio and the expenditure for student is equal or not. In that case, what you can do is first run a regular regression command, and then afterwards you just do this command where test string or str equals expn, and this essentially carries out the joint hypothesis testing.